Hi there everybody, welcome to this session, and in this session we're going to quickly take a look at some if-else's, if and if-else, and what we also commonly refer to as the else-if. So there's an example of an if-else, and here's examples of else-ifs. Okay, which is a little bit misleading. You can never have an else-if if there wasn't a previous if before it. So let's take a look at that quickly here. So in the beginning of the program we just have a simple integer variable called score, and we're going to use it to store our user score input. Then we ask the user to give us a score. We expect a range of 0 to 100 and we store it to score. Alright. Then we're going to test for if it's valid or not, for the validity. Maybe we would like to just increase our user friendliness here. So just give it in brackets the expected range to the user. And then we're going to move on to the next one. So we have an if else here. And with this if else, we're going to test to see is the input valid or not, and give the user corresponding feedback. So an if else is very close to an if. If we take a look at the if alone, so if we just consider this first part, and I'm going to focus on this header part first, you can see that we have an ampersand here, and we are combining two statements with an ampersand. We're checking to see is score more than or equal to 0, is score less than or equal to 100. So that coincides with the lower end of my boundary, valid boundary range, and this is the valid upper boundary range. Okay, so I'm combining with the and, meaning both of them has to be true. The score must both be more than or equal to 0 and at the same time less than or equal to 100. Don't forget the encapsulating brackets. And if that is true, then this printf will run. So if this was a normal if, or just a regular if, yes, then we will print valid. And then the program will move on to the rest. However, what if we also want to provide an alternative? What if we want the structure to give us the option of an alternative? So if it's true, do this. If it's false, do something else. And that's where the else part comes in. So if you add an else after the if, now remember, very important here, else always pairs with an if. So you can never just have an else. You can only have an else if there's a corresponding if for it. Okay, and you cannot have more else's than ifs. However, you can have more ifs than else's. So if can stand on its own, an else cannot. And else always needs to have a matching if, basically. So this else will act or will execute if the if's conditional statement that it's matched to is false. So if the score is not inside this range, then this else will execute and print invalid input, because that is our range for valid inputs. So if the user did give something outside of that range, then this statement will be false and the else will execute, printing invalid input to the screen. Alright, let's quickly see that in action. I'm just going to build and run since I made a small change. So here you can see it's asking me for a score 0 to 100. So if I type in something valid like 50 and I hit enter, just focus on this first line, you'll see on the next line, the first two lines, it says valid input. However, if I run it a second time, and this time I provide an invalid input such as -10, then you can see it shows invalid input. Alright, so you can see that this works the way we expected. Then let's move on to the next part in this code. So here we're using an if else. Actually, it looks like an else if. That's why it's commonly referred to an else if. We're using it to print fail, pass, or distinction. So if we were to take and divide this range of the user scores into three parts: a failing part, which means less than 50, a passing part, which means from 50 to just less than 75 to 74 basically, and the distinction part is from 75 up to 100. If we were to divide it in those three ranges, then we can implement this idea or this desire, this requirement of printing fail, pass or distinction with a structure of else ifs connected of course to the first if. So let's go and see how this works. So we have the if, just like before, we have a conditional statement that can be true or false. If it is true, fine, that will run, it will execute, and it jumps over the entire structure to line 28, which means there's nothing, and it will go to line 29. Alright, if it is false, however, then it will jump to the else, because the else actually matches that if. Just like up here, this else is teamed up or paired with that if. Okay, so then the else will execute. This if, however, is actually inside that else. So the if will only be reached if the else executes, and this if is actually nested inside that else. Though it doesn't seem like it here, this if is actually nested inside that else. And then this condition will be evaluated to see is score less than 75. In this case, if it's true, then this printf will run and the program jumps out to line 28. If it is false, however, then this if is paired and that else. Okay, that if is paired to that else, or actually this else is paired to that if. So if that's false, then it will jump to this else, and inside this else we have an if. This if is nested inside this else. So then we evaluate this condition again, score less than or equal to 100. If this is true, then this will be executed. If this is false as well, it just simply jumps then out. So whether that's true or false, it will, if it's true, the printf line 27 will execute and then it's done. If it's false, your entire structure is then at its end. There's no more else for that if. So it will just jump out to line 28. So just to give you an idea, the other way that you could have coded this, although it's more lines of code, so it's not really recommended, is you could have put this if inside the body of the else. Okay, so it's just a little bit easier to see this way, but if you take a look now, you can clearly see that else is paired with that if. So if this statement is false, then this else will execute. And inside that else is this if. However, that if should be paired to that else. So actually we need to bring this code in here as well. So basically we need to do the following. Alright, I'm just trying to work on the neatness here quickly. Very important for you guys. And let me just take that out for a moment. So you can see now the if and its corresponding else is inside that else. That's what's really actually the case. Although it doesn't look like this with the else if, but you can. And you can see with the else if we saved quite a lot of lines on our code, and it looks a little bit easier. You can quicker see what is the next condition. You just have to remember that if of that else is actually nested in that else, and that else is actually paired up with the previous else above, previous if above it. So the same thing here, there was an else if, so actually what I need to do is create a body and put that if inside the body, because that's actually what will happen. This is the way that C will execute those else ifs. Okay, so you can see that it's actually nesting. If you implement else if, you're actually implementing nested else if else's inside the else of the previous if else actually. So I'm just going to undo this real quick. There we go. So these 4 lines is the same as that entire nested code that I've just shown you. Okay, so you can see it's much easier to read, much more compact. So that's why else if is a popular option, especially if you have multiple nestings that you know that's going to be needed. And then that is it for this code. We're at the end of the program. Let me just build and run here real quick, see that everything looks fine. Okay, now let's run through and discuss some of the outputs quickly. So the first if else is going to test the score variable, which is our input that we are about to provide here. However, all these if else's and down here will also test the same variable score. Okay, so that's exactly why we put the user input to memory, because we want to make multiple tests. We want to perform multiple tests on that score variable. So the first set is to see if it's valid or invalid, and then the second is to determine one of the three categories: fail, pass, or distinction. So let me type a legitimate fail score, let's say 40. I hit enter. You can see this first if else determined that it's a valid input, so that printf ran, and then that was the end. It jumps over, it comes down to the second block of code here, and then it tests score to see in which category, which one of the categories does it fall, starting with the first one. And in fact, this first one is true, so therefore that printf executes, and then after this line 23, it jumps out and goes down to line 28. So that's the fail that you see right there. Okay, now let me run it and just give you another possible input so we can learn from the output here. So let's type something that's just a regular pass. 60, once again you can see valid because this was true, that printf ran, this if ran, so that printf ran. And then we see it says pass down here, so that comes from this block down here. So that means 60. If it was 60 less than 50, that's false. So that printf will not run. It will go to the else, meaning it will go look into the if. Now test, is score less than 75? Yes, it is. 60 is less than 75. That's true. So this printf runs on line 25, and then it jumps out and down to line 28. So it jumps out of all of this, the remaining else ifs, because they are all nested inside each other actually. So that's why we see that pass there. And if we run this again and I provide a distinction mark, 95, so it's once again valid, so that's fine. And then it gets down to this block of code and it printed distinction. That's because 95 less than 50, this is false. So then it moves to the else, it checks this if. Score less than 75, is 95 less than 75? That's also false. Then it moves on to this else, which is the else for that if actually. And it goes into the if, which is nested in the else, of course. Is score less than or equal to 100? Yes, it is. So then that's true, and this printf is inside that if, and it prints the distinction output. And after line 27, it jumps over to line 28. And that's why you see distinction there. So pretty much that's how the if else ifs work. Just one note. Can you see that we have lined up all the printfs in this block of code? This adds to the neatness of your code, so please do not go and tab it in from this if. Okay, it's not a train smash, but it just is not as neat. So you can, in an else if, a structure with else ifs like that, this is perfectly acceptable. Okay, now let's run it again. This time I'm going to provide an invalid input. So what do we expect to happen? Well, we expect this to be false. So the else will run and then it will print out invalid input. Okay, we're all happy about that. However, that's not the end of our code. That's not the end of our program. So if that runs, then the next line is line 20, it's ignored. Line 21 is ignored. Line 22 is reached. Now we're going to test score again because this is part of our program. So it will also run. So now score is going to be checked to see if it's less than 50. So now it depends, do I put in an invalid input that's like very small, negative value, or very big? Let's say I type in -10. If I type in -10, then that will be true. Okay. And then we will actually print fail. However, it's not really a good idea to give any kind of fail, pass or distinction output for an invalid mark because it wasn't valid in the first place. And if I type in something over the range like 120, then you will see that all of them are going to be false in this case. Alright, so in that case it's fine. So it will print out invalid input. This is false, that is false, and this is false. So in that case it will then work out. It will just print invalid input. But if I type in -10, let's see, it says invalid input and then it gave a result, which is not ideal. If I run it again and I just type in 120, it just says invalid input. That's what we're looking for. So now, how can we get not to print out any of these categories if it's a invalid input? Alright, now to do that, you actually have to make sure that this code will only run if that code did not run. Alright, so we would like to show you some nesting. So what I would suggest here is that we have to actually create a body for this else. By the way, before I move on, just as a note, so if you just put a single line like this after the header of a structure, so there's the if, there's a single line, there's no curly brackets here. This is perfectly acceptable. This is shorthand to say that this line of code is the body of that if. This line of code is the body. This line of code here is the body of that else. It's limited to one line only. So if I now want to go and print out something else again, hoping that this is going to be part of that if, it will not be. Even though you indented it, doesn't matter. Only the first line will be accepted if you do not use curly brackets. Alright, so very important note there, just so you know that that is actually acceptable. However, now what I want to do is I want to bring in this entire block into this else. So therefore I only have one line here, but now I want to expand it to be many lines. So I have to create a body here for that else. I want to first and foremost print it's invalid, and then I want to keep on going. Alright, actually I want to do it the other way around. We only want this to be evaluated if it was true, if it was valid, excuse me. So if that condition was true, it's valid, then we want to go and see fail, pass or distinction, not the invalid part. If it's invalid, we just want to print invalid. Excuse me for this. Alright, so let's create that body for that if, since we want to expand the amount of lines of code in it. So we print valid input, and then I'm going to drag all of this. I'm going to basically take it out there and put it in here. Okay, I'm just going to tab all of this up. Alright, so now you can see code looks neat. We print out valid input, and then we go and we test with the same structure, just nested inside this if. We go and see is it fail, pass or distinction. So this will only be performed for a valid score. If it's invalid, like down here, then we do not perform anything other than printing that it's invalid. Let's quickly build this code and run it again and see. Okay, so if I type in -10 this time, I hit enter, now we only see invalid input. Let's just quickly test one or two of the valid values. Let's say 40 again, it says valid and fail. And if we say 60, valid and pass. Let's do the distinction as well, 95, valid and distinction. Just to be thorough, let's put in 120 there, invalid. Alright, now it's great. It's giving exactly the output that we wanted. Okay, and that was it for if else and else if. Now I have an exercise for you guys real quick. So in the commentary up here, I've described some ranges, and I want you to solve this using only if else and else if. Basically what I want you to do is in this program we have in value 1 again, it's initialized to 10, and then you have capture uses score 0 to 100 is the range, and then use if else and else if to print if the score is valid and the symbol for the score. So I would like you to once again test if it's valid or not, and then also go and print the symbol for the score. So how do you determine the symbol? Okay, and that's the ranges that I've given here. If it's 0 to 10, you print I, or the symbol is I. 11 to 20, you print out H, and you can see it keeps on going to 91 to 100 is A+. Alright, so go and take this and go do a review exercise quickly on if else and else if. Okay, that's it guys, thank you.